Okay, so in my previous video, I explained the different lunar phases relative to the position of the moon and the sun. But one of the things that I want to explain that's incorrect in this drawing is that in this specific drawing, the way that the moon is drawn to Earth's perspective, it is as if we have an eclipse every month on this cycle. And the eclipse and eclipse, you have a solar eclipse and a lunar eclipse. It is when the sun, the moon, and the earth are all along in the same line. It's when they are in the same line. And this line here, this is called an ecliptic, E-C-L-I-P, ecliptic. And the ecliptic is the apparent path that Earth takes when it orbits the sun. So anytime in my straight down model, I have our sun, and I have our moon, and anybody does anything like this, what they're drawing is the ecliptic, and it's the apparent path that Earth takes relative to the sun. And then if we have our moon, and we go like that, that is also considered a similar plane. Now, as far as the eclipse goes, you have a solar eclipse, and that is when the sun, moon, and earth are all in the same line. And the opposite holds true when the moon is in the back. This would be a lunar eclipse. It's when they are all perfectly lined up. Now, the problem is we don't have a solar eclipse with every new moon, and we don't have a lunar eclipse with every full moon because the moon is not on a perfect path relative to the sun. That's why an eclipse is so rare. And part of that is because the moon itself has its own inclination. The moon orbits Earth at a 5.2 degree inclination. And let me draw that out. So if we have, okay, this is going to be the horizontal model. So we're going to look at it straight across. So here is our sun. I know it looks like a flower, leave me alone. And here is our earth. And remember, we want to stay consistent, so you have sunlight going in all directions, which means that this half would be shaded and this half of earth would be illuminated. Well, the ecliptic, or the apparent path that Earth orbits the sun, okay, that would be that line there. The moon, on the other hand, is so incredibly far away from the Earth. Now, this is not to scale. Let me write that down. Not to scale. But the moon is so incredibly far away that that 5.2 degree inclination that I was telling you about would look something like this. So here is our moon. The moon is so far away that from here to here, this angle is our 5.2 degrees. And it also extends all the way down. And with that said, from here to our moon is your 240,000 mile difference. So it is the moon is so far away from Earth that this angle, it's only 5.2 degrees, so it's extremely small. But it would have enough effect that in this position from here, this half is dark, this half is light. So here is our new moon. which means that the shadow is going to extend something like that. There's the moon's shadow. And then you have Earth. Earth's shadow. Something like that. And then if the moon were down here, we're going to stay consistent. Moon shadow would be like that. And this is full moon. The moon actually orbits with an inclination roughly 5 degrees. So it is not in a perfect circle in which I drew here. The moon does not orbit the Earth at a perfectly flat line. It is at an angle. Where if you were to take this, now this plane here, like Earth's axis, I'll do it in this color. Like Earth's axis, this was a 23.5 degree difference. When Earth moves around the sun, move our Earth over here. Earth's axis does not change. The direction which it points is still in the same direction that it would be here. They'd still be in the same direction. So if you were to take this model and look at it the other way, the way that the axis is pointed here, in this position, this is summertime. Because the axis is pointed towards the sun for the northern hemisphere. The northern hemisphere would be experiencing summer, and this would be how the moon would appear to us in our perspective. But if we were to take it and extend our drawing out, and let's put Earth on the other side now, over here. So here is our Earth. I drew that bigger than I should have. This side is shaded. I guess I should put a big E right there so we know that that is Earth. Sunlight emits from our sun in all directions. Nothing is blocking our sun. So our Earth has moved from here to over here. The axis in which the direction in which Earth axis point does not change. It is still the same direction in all 3 points here. The same holds true. Let me extend the ecliptic out. There is the ecliptic. The same holds true for the moon. The angle at which the moon appears to orbit Earth also does not change. It's still in the same direction. So even though the Earth has moved around, so here is our moon, and here is our moon. Remember, we gotta stay consistent with what side is shaded. Okay. From Earth's perspective, oh, and here's the angle, 5.2 degrees. This is now for the north hemisphere. This is winter, remember? Because the axis is pointed away from the sun for the northern hemisphere. From this perspective, from Earth looking at the moon, this is full moon. And from Earth's perspective looking this way, this is new moon. And what I want to show, what I wanted to point out, okay, so then this would be from here to here, the moon shadow, something like this. Oops, I'm sorry, I totally drew that backwards. It'd be this way. There we go. Disregard that. And this. Here we go. We've got to draw our shadows consistent. Shadow. Shadow. The apparent path with our moon orbiting Earth does not change. This plane does not change. So because the moon has an inclined degree tilt to it, that is part of the reason why an eclipse is so rare. The moon has to be at a perfect point in which these two line up somehow. And it could be at any point within the moon's orbit from here back to here. This needs to line up within this plane, which gives us our eclipse. Same thing holds true for this side. It would have to line up at some point within the ecliptic for us to get an eclipse. And that is why we don't get an eclipse every month in the phases of the moon per month.